We are going to describe an experiment with a digital generator so we can play with power wavelengths and input speeds. We could change many variables to this formula, like materials and configuration, that will change the results of this experiment. The overall goal is to find the most efficient way to design a power generator and see what forms of power you can create. Play around and offset the second phase or add three-phase with a configuration like that from a car's alternator. Most of the components you can buy from junk yards and chip suppliers like Digi.com. When the coil is charged, it creates a field around the metal. These are called eddy currents. When charge is removed, the metal stays magnetized, but the field is weaker. Now the field can't change as much, so the force applied is weaker, and you are wasting input power. So instead, flip the polarity. The change in the field will go from +1 to -1. This doubles the field change, so we are achieving maximum potential. Now we see the same setup in an array with one coil to generate on top and one on the bottom. This will produce a two-phase power AC current. So when we look at the field flipping in sequence, we get a motion like this. We leave two coils on and two off because the field in between two positive fields will appear as one, and as we roll the field forward, it will induce a constant flow rate. We could experiment with a bigger or smaller pattern of both, but I believe using a single pattern can cause the power to roll back, cancelling out its forward movement and causing it to stall. You can create a timing circuit to flip the field fairly easily, using two transistors on each side of each coil totaling 4 each. You connect two transistor outputs together, one receiving a positive flow and one a negative. On the opposite side of the coil, you repeat this, and you have to wire them so the positive flow from one will be triggered, while the negative is triggered on the other side, and vice versa. You can now cycle between them at half the speed the transistors can move. That will simulate a moving motor rotation. However, a motor experiences load when it's in use and causes it to slow down from magnetic drag. You won't experience that here because it's not moving and the load doesn't change the transistor's ability to open and close. So now look at what a trip to the junkyard would look like. Take an alternator apart and get out the stator, and you can reuse many parts from here. The magnetic stator would likely have to be custom, but wouldn't require movement. The straight design is probably the best choice, but for easy-to-get parts to experiment with, why reinvent the wheel?